So what I think we'll be able to do today is finish off the notes. I'll be able to give you the assignment from 2-3. You'll have tomorrow to work on the assignment from 2-3. Some of you guys have started to finish up your study guide actually and get through some of those. There's a couple corrections we need to make to the study guide as well. But we should be ready to move forward. So we finished off evaluating these limits right here, right? Okay. So as we move to the back side, we can't simply substitute h equals 0 in. Why? Because you would have something over 0, and that's difficult. Even if it's 0 over 0, that really doesn't work. So what we sometimes can do is sometimes the algebra will allow us to just kind of simplify things first. Are you guys worried that maybe she can't hear me very well? This Otton, you probably can't hear me very well. I'm pretty sure that you can't hear me very, very well. Okay, all right. Imagine that Zach would say that. Okay, so if we change this to the limit as h approaches 0, and you can't stop writing the limit as h approaches 0, whatever it is, until you actually substitute that value in. So you need to continue to write this. And what do we get if we square out h minus 2? So that'll be the limit as h approaches 0 of h squared minus 4h over h. So what do you notice now? Right, I can just write this as h minus 4. And now can I substitute in 0? Yep, and I get a value of negative 4. So sometimes it works to simply just, kind of simplify the expression and maybe something will cancel. Go ahead. So plug in the 0. Nope. Okay, F. You guys remember how to do this. How do I cube? How do I cube h plus 1? Very good. 1, 3, 3, 1. H to the third plus 3h squared plus 3h plus 1 minus 1 over h. So using Pascal's triangle, the binomial theorem, those two pieces put together, you understand how to cube something like that. Well, that's going to be the limit as h approaches 0 of the 1's cancel, right? And then an h will cancel from each of the top and the bottom, leaving me with h squared minus 3h plus 3. Am I now allowed to make my substitution of 0? And I get... Sorry. Any questions on that? Okay, let's try something more difficult. This is too easy. Okay, for G, I'm going to argue that for G, the top will factor and allow something to cancel. So here's a little trick for a problem like this. There's a few ways to take care of it. Sometimes we can multiply by the conjugate. You remember that from your college algebra days. But instead of multiply by the conjugate, which is something you could do, I'm going to factor this. This is going to be a quicker method. I have the limit as x goes to 1 of, I'm going to say that the top is the difference of two squares. What times what gives you 1? 1. What times what gives you x? Square root of x. So that is the difference of two squares. We can write it accordingly. Is anybody confused how I got that? Because that's the magic to the step right there. Right, so we cross those off. We can now rewrite our limit as x goes to 1 of 1 plus the square root of x. And you get dos. Yes, I very much appreciate when Miss Brownlow called me. She's an excellent math person herself. She had a math major in college, in case you didn't know that. So, pretty cool. All right. Yeah, she had a math major. So, limit is h approaches 0. Square root of h plus 9 minus 3 all over h. Any ideas here? You could, you lose a finger. That's okay though. It's a good idea. So let's just suggest all the ideas so we get them out there. If you broke this up into square root of h plus square root of 9, maybe your h's could cancel and square root of 9 would be 3 and minus 3 is 0. But none of that's really legal. So none of that's really legal. So anybody have a different idea? Okay, so this is we're going to spend a lot of time in a square root. Well, this is a good idea, but let me show you something real quick. If you have, say, x equals 2, and you would square both sides, you get x squared is equal to 4, right? And so 2 is still a solution, right? However, right, but also there's an equal sign, right? There's no equal sign there. So it's not like you're balancing out the side of the equation. But Cody does have the right idea, and that is he wants to get rid of the square root, right? In fact, the real idea here is that I need to get the h out of the denominator. I got to stop dividing by 0, correct? So I need one of two things to happen. I either need to free up the h in the top and have them divide off, or I need to add something to the denominator. Now, I know that sounds weird, but let's say that there was something more than the h in the denominator. That could possibly help us, right? So I'm going to free up the h on top, and I'm going to do that by multiplying by the conjugate. So multiplying by 1 over 1 does not change the value of the expression, which is what I've done. Multiplying by the conjugate will allow the middle part to cancel, right? That's the beautiful thing about the conjugate is the middles cancel, and so that will allow the square root to be freed up. So now what I have is the limit is h goes to 0 of, what do you get if you take square root of h plus 9 times square root of h plus 9? Just h plus 9. The middle goes away, and then you're left with negative 3 times 3 is negative 9. Over. Now, on the bottom, don't try to distribute stuff. Just write it all in one big piece. H times parentheses, square root of h plus 9, plus 3, close your parentheses. What do you see, Zach? Oh, I thought you said something mathematically intelligent. I'm sorry. I thought you said that you're... So, positive 9 and negative 9 will cancel. I thought you said your h's will cancel. But your h's do cancel, right? Well, the 9 minus 9 gives you 0, so my h's cancel. I'm left with the limit is h goes to 0 then of, what do I have left on top? 1 over the square root of h plus 9, then plus 3. So, yeah, I've added something to the denominator, which was okay, because it allowed something in the numerator to cancel. So, now I can plug it in, and 0 plus 9 is 9, square root is plus 3, so the limit is 1/6. Okay, let's look at this one right here. So, what do you notice about this? Yeah. As Megan said, it's complex fraction. It would, right. So, Brooke did the 100% correct thing, and it's something that nearly everybody will skip. And that is to examine what you're approaching and try to actually plug it in. We always assume that you can't plug it in. Don't make that assumption. There's a problem on your study guide where you can just plug it in, but everybody doesn't do that. They try to do something else and get something canceled first. So try to plug it in. You can't because you get a 0 right there. Otherwise, you know, you'd be pretty close to being able to do it. So as Megan says, it's a complex fraction. Well, let's make it one fraction over one fraction and then multiply by the reciprocal. So if I want to add these two fractions together, I need to have common denominators. So this is going to turn into the limit as x goes to 0 of, I'll have 16 over 16x minus x squared. Very good. Sorry. Sorry. Just so you can see that there's a numerator and a denominator in both pieces. Is everybody okay with that step? So now what I'm going to do is I'm going to multiply by the reciprocal. And the reciprocal in this situation, the limit as x goes to 0, if I see that something factors, I should take that and use that to my advantage right away. What is 16 minus x squared factor to? I want everybody to understand this too. 4 minus x times 4 plus x is different than x minus 4 times x plus 4. The order does matter here because you have a negative. It's different by a factor of -1 over 16x times 1 over x minus 4. You sure can. Now what we have here is the limit as x goes to 0 of negative times x minus 4 plus x over 16x times 1 over x minus 4. What happens? X minus 4's cancel. Does it work to plug in 0? It still doesn't. So, well, Larry brings up a good point. It may not exist. So if you can't confirm it algebraically, what should you do? So let's take out our calculator and graph it. You haven't seen this one before, have you? It was? The screensaver changes it every once in a while, so. Well, no. We want to graph the original function, and I'm going to put parentheses around so I know what I'm doing. Looks like I'm going to have 1 over x minus x over 16 divided by x minus 4. So that's what I'm going to plug into my calculator. Make sure I get my parentheses correct. Parentheses, 1 divided by x, parentheses, minus x divided by 16 and if I zoom in a standard viewing window, you can see I get that. I can't really tell what the heck is happening there. Which number do I want to move in on? Do I want to move in on 4 or 0? I'm moving in on 0, so I'm going to zoom as a box, and I'm going to kind of try to control the output here a little bit of what my graph is showing. Yeah. Oh. So the zoom is a box. It's just so now remember, I know this is a while ago, but I do know who your college algebra teacher was, and I know that he gave you a really good graphic calculator worksheet that made you graph like a box at one time. A zoom box was just zoom 1, and then you just go ahead and make it. Now, in order to evaluate this limit, we need to approach it from the left as well as the right, correct? As you approach 0 from the left, what is the output approach? As you approach it from the right, what is the approach? So therefore, limit does not exist. So we weren't able to verify it algebraically, but we can say this limit does not exist. Okay, so Megan said, why not check it beforehand? You sure can check it. However, I wanted to show you guys how this problem would work out if you were able to get something to cancel algebraically. So just a reminder of your complex fractions. Okay, last example. We want to plug in -5. The absolute value of -5 plus 5 is going to be 0 over 0. This does not work. Shh. Boys, girls. Shh. So remember that an absolute value can have two possible values. It can have the positive as well as the negative, right? So you can really consider this as the limit as x goes to -5 of either -x minus 5 over x plus 5, or the limit as x goes to -5 of x plus 5 over x plus 5. Right? Well, we'll look at the graph and we'll see exactly what's happening here, but what could you factor out of this? Yeah, so you got the limit as x goes to -5 of -1 times x plus 5 over x plus 5, which will just give you -1. And this one up here, the x plus 5 and the x plus 5 cancel to give you 1. So this function has a constant value of -1 for part of the time, and has a constant value of +1 for another portion of the time. So let's look at the graph. And if you want to do it on yours, that's fine. If you don't, that's okay. I'm going to go into my y equals. And if I want to type in absolute value, there's a number of ways to do that. I like to grab my absolute from the catalog, because it's the first one. So I have the absolute value of x plus 5. Let me divide that by x plus 5. And when you graph that, whoop. What do you notice is the value of the function behind -5? -1. What's the value of the function after -5? +1. So if you're approaching -5, you have to approach from the left and the right. And you can see that from the left, the output is -1. From the right, the output is +1. So therefore, the limit does not exist. Now, just watch. What if I did this? Then it would be +1. And if I did this, yeah. So those are that's the difference between doing a left-hand limit, a right-hand limit, and a complete limit. So make sure that you keep that in mind. So that's it. You guys have the rest of the hour to work, which is 25 minutes. You're going to have a work day tomorrow, and then study guide on Wednesday. Your test is on Thursday. So please use your time wisely. I'll write your assignment on the board. We'll be good to go. there's your assignment.